start on the current slide. Now, I had planned today, first thing, to give all your papers back, but because there's people taking tests, you know, within earshot, that I don't want, you know, to be discussion about the test, you know, y'all asking me questions and stuff. Can't answer those while people are taking those tests. So I'll give those back to you right at the end of the class. So don't leave here without it. If you have to leave early, tell me. I'll stop and give your papers back then. Now, I will apologize ahead of time. It won't affect more than a couple people. One that I can think of, no, two in the room right now, is I tried like everything to get them all graded last night, and I just ran out of steam. So I think Quinn and Rhodesia, you're bottom of the alphabet. I didn't get to yours, sorry, but I did get everybody else's graded. Now, some have come in this morning I have graded, of course. So I'll get all the rest of them back, and your earlier, too. And by the way, if any of you had earlier tests that you didn't see a grade on Blackboard, that means I wasn't sure if you were finished with it. If you've seen your grades on Blackboard, that means it's in the book, so it's okay. But if you don't see it there, it's because I wasn't sure if you were finished with the test. So if you don't see your grade on Blackboard, then let me know, and I'll let you finish those tests if you want to. Otherwise, I'll give you the grade that's there. No problem with that. All right, any questions? No, the one you just took. No. Yeah, the first one. Yeah, I got yours graded, but I was still grading papers last night, and I didn't have time to put it in Blackboard. There's just too many to do. Someone else coming in? Oh, okay. I thought someone else was coming in. The door is unlocked, isn't it? Okay.
You have a sign on the door that says 205.
Oh, yeah, well,
the other door says.
Yeah, well, I wanted you running back and forth. You need the exercise, right? Okay. No, I'll explain in a second. Okay. What happened is someone stole the projector from that classroom, and so there's no projector, so in order to have a projector, we're here. Okay. And we knew it would get you to the front of the classroom, so that's the other reason. Okay. So anyway, here we go. Any questions about anything so far? Let me just go over quickly. Now, before you leave today, pick up your quizzes and tests. Okay, before you leave today, pick up quizzes and tests. Don't give them back early, but people are taking tests now, so I can't go over them with you anyway, so we'll just hang on to those until at the end of the class. If you have questions, come see me. And so that leads into what happens now. I'm going to be in class almost all day today, basically from now until 5:45 I'm in class, okay? I've got little 15 minutes and 30 minutes here and there, but that's all. So can't get with you then. But I am on the Birmingham campus tomorrow. It's the Birmingham West campus. That's the B building, which is the academic building. I'm there from 8 to 12 tomorrow. So if you do have questions on the things I returned to you today, good time to ask. Okay, I'll be over there from 122. If you're familiar with the Birmingham campus, in the middle of the West campus, there's a sort of a, not quite circular, but a drive around that goes around 4 buildings and a quad. Okay, the building this way is the administration building, no classes in there. It's the A building. The B building is the big, long building in the back. That's where I am. I'm on that end, the end toward the gym, the tennis courts, and the baseball field. Okay, that end. And when you come in that door, you have to either go down half a flight or up half a flight. Go up half a flight. When you step on the top step, first door on the right is 122. That's where I am. It's Dr. Carl Pruitt's office, and Miss Rose Saxon's the secretary. I'm in the copy room there. Okay, so that's tomorrow. Monday, I do have class, but I have office hours between 8 and 10 and between 4 and 6, 3:45 and 6. So catch me either the beginning or the end of the day, and I can go over anything with you then. Okay? Now, in between that, from 10 till 3:45, I'm in class just about the whole time. I have 45-minute lunch and 20 minutes between two other classes, but that's all I've got. I'm in class otherwise. Tuesday, okay. Let's talk about Tuesday. I wish more people were here. Tuesday, we will be back in 205. I don't need the projector to give an exam, okay? We won't be using the projector. You'll have plenty of room to spread out, so we'll be back in 205 on Tuesday, okay? Now, the other thing about Tuesday, they did come out with the exam schedule. I think I told you this before. At least two things wrong on it. Number one, they said class A, just it right? Okay. And Thomas. Okay. Now, two things wrong about the exam schedule that was sent out a couple of weeks ago, maybe 3 weeks ago now, something like that. Number one, they say finals start on Monday. They don't. They start on Tuesday. That's why I have class Monday. TK's here. And Jayla's here. All right. Does anyone else come in since they called off? Okay. Now, for those who just came in and you're wondering about it, why are we here? They stole the projector in room 205. Okay. And they did it in broad daylight. Sometime between, they said sometime in the afternoon between stuff like 1 and 6. They knew it was there earlier, and then it wasn't there later, okay? And we have campus police, supposedly, monitoring cameras all the time. So, don't know. Obviously, they're not monitoring cameras all the time, okay? What's that?
It was the police that did it.
Well, I guess it could be, but makes them walk all over the place and they aren't going to unlock a door until the instructor is there to request it to be unlocked. Okay? Now, I have a key to this one, that's why I could get in here. And I let Ariana in because she was the first one here. And then I went on without. Okay, so number one, finals start on Tuesday. Now, the other thing weird here, I don't know why they do it, but they, even though classes start at 8:30, they still start finals at 8. Because we used to start classes at 8, so they did everything how we used to do. They didn't change that. Why, I do not know. Okay, Carla, there you are. All right. Now, do you need to take the second test? Have you turned in the second quiz? I need the second quiz first. Yes. You want to finish yours, okay? Okay. So you're going to work on the second quiz first?
I'm finished with it. I'm done.
Are you going to turn it in?
I talked to class.
Okay. Well, I need you working on the second test now. Okay. 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 Thank you. Okay. I graded what you had done so far. Now, if you want to go in one of the two offices back there, I think there may be some free chairs, or you can work on it here, whichever you prefer. Okay? You're going to go where it's quieter? I thought maybe that. Okay. Yeah. Along the right. Okay. Found you, now I've lost you again. There you are. Now, if all the chairs are taken back there, I'll find another room. Where are you heading? Okay, there's a class in the one next door. I said, wait a minute. It looks like she doesn't have a seat either. Excuse me, I'll be right back. This is so much fun, isn't it? Oh, now he has to wake up. I'm sorry. Okay. Okay. Will we ever start class? I don't know. Let's talk about final exams. So the point being, I want everybody to hear this. The final exam on Tuesday starts at 8 o'clock, not 8:30, okay? Now, I'll try to be here. I'm used to getting here right at 8. I'm going to try to get here early so everything will be set up. Again, we will be in 205 then. We don't need to be here for the final because we won't need a projector for the final exam. All right, any questions about that? Okay. Now, the next comment I should have said very first. Has everybody done the student course evaluation? Okay, if you haven't, please do those. Please do the student course evaluation. Okay? Let's see, what else? Okay, let me give you the rest of my schedule for the rest of the week. So Tuesday morning, 8 to 10, basically 8 to 9:50, we're down in 205 with the exam. After that, I'm back in the classroom. Until 1:15. I mean, back in my office until 1:15. So I'm in my office from 10 to 1:15. At 1:15, my second mini-term class, we still have class that day. So we have class at 1:15, and we will be there. I doubt if we'll be there until 5:45, but that's when technically it goes. It won't be enough for us to do that long, but sometime between 1:15 and 5:45, I'll be back in the office again until 6 o'clock. Okay? After 6, let me get Amina here. I know you're in here. There you are. All right. Now, I think I got time to say. I think I got everybody. So, after that class is over, I'm back in the office until 6 o'clock on Tuesday. On Wednesday, I have absolutely no finals scheduled. So I'll be in my office from 8 until 4 o'clock. At 4 o'clock, I'll leave to go to the Birmingham East Campus, and I'm there from 4:30 to 6:30. Okay? So if you need me, that's where I'll be after. Between 4 and 4:30, I'm driving over there. At 4:30, I'll be over there. Okay? Then Thursday, I have one final scheduled. Again, 1 o'clock, in this room. Okay? It won't take long, so after that's over with, I'll be back in my office. So from 8 until 1 in the office, from 1 until the final's over, I'll be here. And then from when the final's over until 6 o'clock, I'll be back in my office. Friday, I'll be back on the Birmingham West Campus from 8 to 12. Did I say that about tomorrow? I may not have. Tomorrow I'm on Birmingham West Campus, 8 to 12. Then Monday of the following week, I have no exam scheduled, but you can still come and see me, whatever. I'm here from 8 to 6 down in my office, okay, 265. Okay, we're also here Tuesday and Wednesday, and we're here almost till the end of the week on duty days. But are any of you graduating this term? One, okay? Just one, okay? I've got to get your grades in by noon on Friday, so be sure you get everything finished by then. If you're here for your final on Tuesday, it shouldn't be any problem, okay? But if you owe me something like a research paper, let's talk about the research paper. Any that haven't come in yet, after today, after class is over today, you'll start losing points. I will take them later, but you'll be losing points. So please get those to me as soon as you can. So I can't remember if you get on yours or not, but if you get, I can't receive yours, Thursday's the last day I can get yours, okay? Because I have to have your grades in by Friday. Otherwise, you may not be graduating. I don't know. Okay, you don't want that to happen. All right, the rest of you, everything has to be in. Everything has to be in by Monday because Wednesday at noon I have to have the rest of your grades in. So I have to have everything in by Monday. Okay. So, any questions? That's gory detail, but hopefully covers everything. Any questions? All right. Has all this been turned in? No, a lot of it's turned in today, but some of it not. Okay, and again, before you leave today, pick up your paper things. I do need everything submitted, all your tests and things finished today. So if you haven't finished the test, please, this is the time to do it. Because once I return the papers, I can't let anyone else do a test. Because the word's out. Okay. So, if no questions, last time we were talking about exponential functions. Okay? Now, we were talking about how in the world can you raise a base, any old base, let me take back that, any base, positive base, not 1, okay? Anything greater than 0 except 1. Anything between 0 and 1 and greater than 1. That can be your base. No negatives as the base, okay? How can you raise that to an irrational number, power? Well, you can approximate it by starting with just that term, a to the 1.4. You'll get pretty close. 1.41, 1.414, 1.4142, 1.41421. You can approximate it as close as you want to go. Okay? After a while, the answer looks the same. Stop, and that's as close as you can get. It's an irrational number as well, so you'll never reach an end. Okay. Is that test 1? You ready for test 2? You need graph paper? Huh? I'm sorry.
No.
You don't need graph paper? Okay. I thought I had a test 2 here on top, but other people have done other things since then. Well, I don't know where it went. Ah, there it went. Okay. Now there's 2 to graph there. You don't need graph paper? Or you still got that? You got that? Okay. All right. So that's how we approximate a base raised to an irrational number. You just use as many digits as it takes to get as close as you want to the final answer. Okay? So, I hope y'all have calculators now that Jamina's here. Okay. Do you need to take the test?
Yes, sir.
Okay, have you turned in the quiz? Second quiz? Let me see. No, I don't think you have.
Okay, I'll check for you.
What's that?
I'll check for you.
Okay. And you need to finish that first and then take the test. But you got to take the test today.
Okay.
Okay. And I can put you in another room if we can find one open. And to explain to people who have come in late, why are we here? Someone's told the projector in room 205. So therefore, we're here. Okay, so we could have this room. And why I can't put people in 251, they will not unlock a door unless an instructor's in the room. And I can't be in that room while they're taking tests while I'm teaching here. I haven't figured out how to do that. I'm not schizophrenic enough to do that. So that's why people are taking tests in the offices back there. I could get into that room, but a class showed up there. So, you got calculators? You'll need calculators if you haven't realized that on your test. Okay? Let's use a calculator to evaluate each function at the indicated value. 2 to the x. That's the function. Now, how do you do that on the calculator? Let me get my pen set up. Okay. You press the number 2 and then look for the key. On most of the modern calculators, it's the caret key. Okay? The little house top. okay, A-frame, okay? And then you type in negative 3.1. Now, most current calculators, that would be look for the negation key that's inside parentheses, okay? The negation key inside parentheses, not the subtraction key. The one over near the plus, minus, and times key, that's not the one you hit. You don't hit. Same symbol, but don't hit that key because that's subtracting. This is the one that changes the sign, okay? And then you type in 3.1, and then you press equal. Now, if that doesn't work on your calculator, let me know and I'll try to figure out your calculator. Because different calculators have different syntax. This is what most current calculators use. Some of the older calculators, rather than the caret key, they'll have a key like this. X to the Y, or Y to the X, or A to the B, or B to the A. Some key like that. That's the same one that's this caret key. Just press that key instead. Okay? Whatever one happens to be on your calculator. See what you get as an answer. Anybody?
0.11.
Say again?
0.116.
Okay, let's see what we get. 0.1166291, blah, 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 blah. Okay? See how that works? Okay, there's those same keystrokes, but I don't know if your calculator do that. Graphing calculators, most of them use this. It's fairly standard. Okay? Anyone not able to get that on your calculator? Okay. Are you using a calculator or a phone? Okay, calculator. Okay. Yeah. Okay. Yeah, that's the key. So you use 2, then press that key, then press the negation key. Oh, wait, okay. Now, yours is that you press the number 3.1 first. 3.1. And now you get that key. And then okay? And then press it. Yeah. Get it? Okay. Okay. Huh?
We got the same.
Okay. So let me see how y'all do it. 2. And you're looking for, okay. You see the Y to the X, or X to the Y key? Yeah. Press that. Okay. Now your negation key, oh, yours is plus minus. So that means you enter the number first, 3.1. Yeah. So you did 3. Oh, you did. All right. Okay, good. Negation key, now press enter. Or equal. Yeah. Got it? Okay. Wait. Did you start off with the 2?
No.
Okay, sorry. Okay. Start with the 2, and then you press this key here, the X to the Y. Yep, that key. And then, because you use the plus minus key, you put 3.1 first, and then you change sign, okay, and then press sign. Okay. Everybody got it? Yeah. Okay. Yours. There's your caret key. Okay, you got that one. And there's your negation key, 3.1. Okay, that's it. Anyone else? Everybody know how to run your calculator now? Because you'll need to know that if you're doing exponential functions. Okay, let's go back to the second one. So how would you do this? Tell me the keys or approximately that you would do. 2 to the negative x, where x is pi. Do all of you know how to find pi on your calculator? There is a pi key somewhere there. If there's not, you can use 3.1416. That's going to be close enough. So with your calculator, punch it in and tell me what you get. See, we in the South are pretty violent. We punch our numbers in. In the other parts of the country, they press the keys. We punch them. Okay. So, anyone got an answer yet? Okay, what you get?
0.1133.
Okay, awfully close to what we had before. 0.1133147. Okay? So this was 2 to the minus 3.1. This is 2 to the minus 3.14156. You know, okay? So it's a little bit different. And because it's in the denominator, you go up with this. Your answer goes down a little bit. Not got it? Okay. For your calculator, it'll be 2, and then you do the a to the b or x to the y or whatever your key is. And then you do the pi key. Did you find the pi key? And then you negate it with the plus minus key, or change sign key. Okay, and then press it. Okay. All right. Now y'all can practice together, but we don't do it together on the test. Okay, never mind. Okay. All right, everybody got it? Okay. Let's go back to this one. 0.6 to the 3/2 power. How in the world do you do that? Give it a shot. Yeah, okay, how do you do the fraction? And, okay, let me go and line it out for you. Now, this will be for certain types, not, you figure out what to do on yours. 0.6, and then it's either the caret key or one of those keys, and then you open a parentheses. Won't be up there, but open parentheses, do 3 divided by 2 and close the parentheses, and then press equal. Okay? Easier than that is 0.6, and then whatever key you use there, and just then do 1.5. You can do that in your head and press equal. That'll give you the same answer, because 3 divided by 2 is 1.5. Okay? How are we doing on answers? 0.46. Let's see what we got. 0.4647580. Hike. Okay. Never got it. Okay. Everybody got it? Anyone failed to get it? Okay. That one you had no sign changes. Notice here, if you're doing the division, then you open parentheses there. Otherwise, the computer is going to do 0.6 caret. If you press the 3 next, and then divide by 2, it's going to first raise that to the 3rd power and take that answer and divide by 2. That's why you've got to have the grouping symbols here, because the calculator does exactly what you tell it to, and it generally obeys the rules of order of operation. Please excuse my dear Aunt Sally. Whatever she did, I don't know, but please excuse her. And if you do the exponents come before division. So then your calculator is going to do 0.6 raised to the 3rd power, and then that answer is going to divide by 2. You put it in parentheses, then it completes first, so it does that first before it does this. Okay? Anyone not yet? Oh, yeah, you got that answer. Everybody see how to do it? All right. Good deal. That's example 1. Okay. Now, the next subsection here is graphs of exponential functions. How in the world do these look? Okay? It says on the same coordinate plane, sketch the graph of each function. Now, how do you reckon you're going to sketch the graph? Okay? Yes, you're going to pick some x's, plug them in, and see what the y's are. So let's just do some x's. 1, 2, 3, 4, 5, 6, 7. We won't need that many. Negative 1, 2, 3, 4, 5, 6. Notice I didn't do any negative numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And you'll see why in a second. Okay? Now, I'm going to start with an easy x. Give me an x. 0. I love it. What's 2 to the 0? 1. Anything to the 0th power is 1. So when x is 0, 2 to the x is 1. So I'll do this one in dark here. Okay? Let's give me another easy x. 1. Very good. What's 2 to the 1st power? 2. Okay, we're in there. So when it's 1, we're at 2. Got it. Okay? Let's do negative 1. What's 2 to the negative 1? 1 over 2. Raised to the negative power means it's in the denominator. And what's 1 over 2? 1/2, right? At negative 1, you're at 1/2. How about 2? What's 2 to the 2? 4. Okay, we can do that. At 2, you're up here at 4. Okay? How about 3? 2 to the third. 8. You're at the 4, 5, 6, 7, 8, and we're already going off scale after that. Now let's go backwards a little bit. 2 to the negative 2. 1/4, absolutely. So that would be down here. Okay? 2 to the negative 3. 1/8, that would be down here. Negative 4 would be 1/16. 1/32, 1/64. They get closer and closer to 0, but never get there. That's why we didn't need any negative numbers. So this is what your graph looks like. And it takes off and goes up really, really fast. That's what we say. If you ever hear anyone talk about exponential growth, that's what they mean. It grows big time. If y'all been hearing about the measles epidemic, guess what? Exponential growth. Shoo, it takes off and goes. And I hope I'm not going to offend anybody, but I sure hope all of you are vaccinated. Okay? And I hope you and your kids and everybody else is vaccinated, because it's measles can be a pretty tough disease. Okay? It can affect vision, heart. There's all sorts of things it can affect. Now, back when I was young, I don't know if there was a measles vaccine, but I got the measles. And my mother said you could not put your finger on any part of my body that was a red welt. And it was pretty miserable. I had to stay in the dark, because the light would bother eyes. She was a nurse, so she kept everything really good. But people caught it back then, but people suffered from it. So you don't want your kids going through that. Okay, please get them vaccinated if they aren't already. But diseases spread that way. Bacteria spread this way. It's just all sorts of things go by exponential growth. In fact, our use of fossil fuels is exponentially growing. When I say ours, I say the world's use. Hey, guess what? Fossil fuels aren't being produced exponentially. In fact, that's a very slow process. We're using fossil fuels now that were planted in the earth millennia ago, and we're using them as fast as we can get them out. Guess what? There is a point of no return. Okay? Alternative fuels, that's the future, folks. Oh, that was political, sorry. Let's do the B. Let's do the B in a different color. Pick a color. Any color, other than the one we're on now. Red? Okay, we'll go with bright red. Fire engine red. If I can get it to pick. It won't pick. There we go. Okay. Let's do G of X. 4 to the X. Give me an X. A real easy one. 0. What's 4 to the 0? 1. Excellent. Right there. Same place. Okay, give me another easy one. 1. 4 to the first is 4. We're up here. Wow. 4 to the second. 16. Already off scale in just 2 sticks. About 4 to the minus 1. 1/4. Minus 2. 1/16. Okay, somewhere down there. And then 1, goodness gracious, 64th maybe, or something like that. We're getting close to 0 very, very early, but going hugely, rapidly up. So the larger the base, the larger the more rapidly it climbs. And on this side, the more quickly it flattens out. Near 0, but never reaches 0. It doesn't tail up either, but it's just my lousy graphic. All right. Okay. It was still too loud back there, wasn't it? Yeah, I can tell. Okay. Good deal, thank you. Okay. All right. You see how graphs of exponential functions look? They're very flat on one side, but never negative. Approaching 0, but never getting there. So you do have a horizontal asymptote here. Not on that side, but on this side of 0. Okay? But there's no vertical asymptote. They just keep climbing and climbing and climbing and climbing and climbing. Okay? So, that's what exponential graphs look like. That's what they mean by exponential growth. Okay? And just, I don't know, we don't have time for it. I had a really dumb example, but we won't do it. Okay. Let's see how they do it. Let's erase my ink. And here they showed them both at the same time in the same color, which makes it really hard. Here's f of x equal 2 to the x goes up like this, 4 to the x goes up like that. Flatter here, the steeper there. Okay. Everything passes through 0, 1. Everything passes through 0, 1 on exponential functions. Okay. Now we're going to do something a little different. Well, wait. Note that both graphs are increasing. One thing to notice, both graphs increasing. Notice the graph of 4 to the x increases more rapidly than the graph of 2 to the x. Okay? Even down here, it's increasing. Well, I don't know. You can't say much on this side, but on this side, it's increasing more rapidly. Okay, another thing, always positive. So what's its domain? Domain. All real numbers. What's its range? All positive real numbers, greater than 0, not greater than or equal to, greater than 0. It does have a horizontal asymptote of y is equal to 0, no vertical asymptote. Okay, test 2. Okay, I had one out for you, but I gave it to someone else, so hold on a minute. Do you need graph paper? Okay. Test 2. That's not it. There it is. Well, there's 2 to graph on it. You still got graph paper from before?
Yes.
Okay. All right. Did you ever find your quiz? What's that? I'm supposed to return them all today. You want to work on it again? I don't know. Okay.
It's at home.
Huh?
It's at home in my notebook.
Okay.
I'm going to go drive back home and bring it back to you.
Okay. Okay. Well, okay. Okay. All right. Second? Okay. All right. So, those are things to note about the graph of an exponential function. Let's see. Before we hit here, we need to go back and do another one. This is example 3. Oh, yuck. Oh, I forgot I did that. Okay, example 3. Let, on the same coordinate plane, sketch the graph of these functions. This time they're calling it capital F of x, for no special reason, is equal to 2 to the minus x. Okay? And then we'll do capital G of x is equal to 4 to the minus x. Okay? All right. We'll draw my graph like I did before. Okay. We'll tick off some points here. Okay. Give me an x. 0. 2 to the 0 is 1. There we have it. I told you they were all there, didn't I? Give me another simple x. 1. 2 to the minus 1 would be what? 1/2. Perfect. Okay. Give me another x. 2. 2 to the minus 2 is 1/4. Minus 3 would be 1/8, 1/16, and there we go. We've seen that before, but on the other side. How about when it's a minus 1? 2 to the minus a minus 1 would be 2. Okay, so we're right here. Minus 2 would be 4. Minus 3 would be 8, somewhere up here. And minus 4 would be 16, off scale already. There we have it. Okay? You want red for G again? Or you want a different color? Somebody. Same thing? Red. Okay. So, when x is 0, what's 4 to the x? 4 to the 0? 1. So there we are. All of them pass through 0, 1. Next. 1/4. Next. 1/8. No, 1/16. You're right. 1/16. And then 1/64. I mean, they go down really fast. And when x is 1, you're at x is -1, I'm sorry. X -1, you're at 4. -2 is 16. Already off scale before you get there. So here is your graph of the other one. Steeper to the left. Now tell me a few things about this. Always decreasing. Always decreasing. Okay? Another horizontal asymptote. This one to the right. And it should never cross it, but it's okay. It never becomes 0. It just gets closer and closer. Okay? No vertical asymptote. It just keeps climbing, climbing, climbing. Okay? So this is what we have going on here. Now, can you think of anything that behaves like this? Have you ever heard of carbon dating? It's like Match.com, but with carbon atoms. No, I'm just kidding. It's nothing different. Okay, no. All right, carbon dating is what you do. You measure the amount of carbon in any kind of a fossil, and depending on how much of that one weird isotope, carbon-14, I think it is, they can estimate how, because that decays at a very slow exponential rate. So if they have a certain level there, they think it's about this many thousand years old. Less, they think it's that many thousand years ago. Like that. The trouble is, it's an awfully flat curve. So if you're off a little bit on your estimation, you can be anywhere between there and there. So that's why carbon dating is not precise, but it gives them a general ballpark of where they think the age of the fossils are, because that radioactive materials decay at an inverse exponential rate. That's how they do estimate the age of ancient things, anything that has living material in it. Okay? So that was example 3. All right. Now what we've already said is this. Those are the table for example 2. All right. The following summarizes the basic characteristics of the exponential function when x is positive and when x is negative. Okay? Domain, all real numbers. The range, 0 to positive infinity, but 0 is not included. Okay? The y-intercept is always 0, 1. No matter what exponential you have, which way it's going, they all pass through 0, 1. If this is positive, a is greater than 1, of course. Okay, yeah. A is greater than 1, and x is greater than 1. Well, whether x is greater than 1 or not, you're increasing. Always increasing. Okay? The x-axis is a horizontal asymptote, especially on the negative end of that, and it's a smooth, continuous function. Smooth and continuous. Not like polynomials are smooth and continuous, and exponentials are too. But the big news here, never negative. Okay? Now, if a is greater than 1 again, and you're raising this to a negative number, or negative x, then you have the reverse of that. It's always, okay, same domain, all real numbers, same range, 0 to positive infinity, but not counting 0. Y-intercept is still 0, 1. There is no x-intercept, by the way, none, ever. It's a decreasing function now. This would be like radioactive decay. The x-axis is a horizontal asymptote to the right, and it's a smooth and continuous function. Notice that the graph of the exponential function is always increasing or always decreasing. It never changes direction. Never. Okay. This is any exponential function. If you had a bigger A, it would be steeper here. But it still follows the same pattern. Okay. As a result of this, remember when we talked about functions that were always increasing or always decreasing? We said those were one-to-one functions. Not only do they pass the vertical line test that every function must pass, they now pass the horizontal line test that one-to-one functions pass. So all exponential functions, whether they're decreasing or increasing, are one-to-one functions. Okay? Now, because of that, you can use a one-to-one property to solve some very simple exponential equations. Now this again is with a greater than 0 but not equal to 1. That's always the case for exponentials. With a to the x, the same a to the x is equal to a to the y. Because it's a one-to-one property, x has to equal y. There's no way around it. Because there's only one place where a to the x and a to the y will be the same. That's when x is equal to y. If it's the same a, only way it can be. Okay? So that should be pretty patently obvious. Hopefully it is. Now, it seems like there should have been some examples with that. And I think so. Example 4, before we get to the natural base e. How are we doing on time? Okay, we got a few minutes. So let's do this one. Yuck. Okay, we'll clear this out of the way. All right. Get my dark pen back. Okay. Example 4. 9 is equal to 3 to the x plus 1. How in the world could we solve a bizarre-looking equation like that? Say again? Divide a graph?
X.
Huh?
X.
What about x?
We graphing, right?
No, you don't need to. Please, let's not. Okay. That's too tedious. Let's do it algebraically.
Solve for X.
Okay, solve for x. How do you do that? Oh, there's a problem, isn't it? Here's the key. If you can get this to the same base as this one, then we can use the one-to-one property. So, can you write 9 as some power of 3? How? What would that be? 3 squared is equal to 3 to the x plus 1. Now, what does that tell you? It tells you we lost the slide. Okay. There it is. Okay. What does that tell you? That 2 is equal to x plus 1. And don't you see? If the same base is raised to powers and it's the same value, they have to be the same powers. Right? So even this I think we can figure out, can't we? What is x equal to? 1. Yeah, subtract 1 from both sides and you get 1 is equal to x. Perfect. Because 1 plus 1 is 2. High level math today, right? Okay, so, yep, that's the A part. X equal 1. How about this one? 1/2 to the x is equal to 8. Oh my goodness, bless you. Okay. How do we do that? Huh? 2 minus x? Is that what you said? Oh, okay. You're saying that this is the same as 2 to the minus x. Is that what you said? That's a good observation. Goodness gracious. And that's equal to 8. Can you express 8 as a power of 2?
Yes.
How? 2 to the third. So therefore, minus x is equal to 3. Therefore, x equal negative 3. Perfect, perfect, perfect. They even got it right in the book. There are a couple of checkpoints. Do those. You'll find if you can't get them right, audio video solutions are at LarsonPrecalculus.com. Okay. Now let's see. Are we ready for the next? No. They skipped example 5 too, didn't they? Okay, so let's do example 5. All right. And by the way, this example is you can see LarsonPrecalculus.com here for an interactive version of this type of an example. Describe the transformations of the graph of, y'all like these transformations, I can tell on your test. Y'all always love these. Okay. The book loves them, I'll tell you that. Okay. So here we have f of x is equal to 3 to the x. Okay? And it says describe how the transformation of the graph of that function, if we did graph it, if we went to g of x equal to 3 to the x plus 1. Okay? Tell me what you've done to this to get to that. A little louder?
Oh, no.
Okay. Up 1, you said? What have you added 1 to? The x. The x is on the horizontal axis. So let's guess again.
So you shift.
Shift to which way?
No, left.
Left! Because everything in the x-axis is backwards. Okay? So you shift to the left 1. And if you look at the book, okay? All right? Look at the book. I'm going to try not to draw because we're out of time. There was after the 3 to the x. We're used to seeing that one. When you change this, shift 1 to the left, so everything gets moved here. This goes left 1, this goes left 1, this goes left 1, that goes left 1. They all moved 1 to the left. Therefore, this one doesn't have its y-intercept at 0, 1 because that got shifted to the left 1. Okay? So there's a transformation just like we did with polynomial functions. You do the same thing here. You shift horizontal shift 1 to the left. Okay? So how about this one? Let's do a different one here. Different color. Though it doesn't really matter. We'll go back to red. I thought I went back. Yeah, there I did. H of x is equal to 3 to the x minus 2. 3 to the x minus 2. What is that going to do?
Go down.
Down 2, exactly, because it's the y value here, that's your y value, that gets reduced by 2. And when y is reduced, it's reduced. So sure enough, this one goes down by 2. Okay? So here was your intercept here, 0, 1. It goes down to 0, minus 1. So again, your intercept gets changed. This value here goes down 2, down 2. Now this doesn't look like it's happening, but sure enough it is. This was at 2 here, at 1, at 1, 3. We can't see it. 1, 3 was up here. You go down 2, and now you're at 1, 1. Okay? So sure enough, that's what it is. It looks like they're not parallel, and they're not parallel, but everything is shifted down 2. Okay? Let's do the next one. Let's pick another color. Any preferences? Second? Purple. Okay, we'll do a purple. And this will be our k of x is equal to minus 3 to the x. K of x is equal to minus 3 to the x. Now tell me what that means. Second? Yes, exactly it. It's not negative 3 raised to the x power because we don't ever have our bases being negative. Remember, please excuse my dear Aunt Sally, you raise this first and then you negate it. So yeah, that's a reflection across the x-axis, and that's exactly this. Poor people at home, they can't see me hold the book up here. Okay? But you see, you just reflect everything across the x-axis. So there's the graph down here. Now your y-intercept is 0 minus 1 because you reflected across the x-axis. Does that make sense? All right. Let's do the last one here. And this is what color now? Second? Orange. Aren't you? Okay, special. Okay. This will be j of x. J of x is e to the minus x, 3 to the minus x. What in the world is that doing? Second. Reflecting across the y-axis. Here you negated the y value that reflected across the x. Here you're negating the x value that reflects across the y. And sure enough, here's the graph for that. Everything that was over here is now over there. And we saw that before when we did our graph. Okay? One way it's going at exponential decay, the other way is exponential growth. Okay? Just the exact reverse on those. The y-intercepts are the same. Now, I know we don't have much time.
Still be on the center?
No, I'm going to leave this off the test. But I didn't want y'all leaving early, so I didn't tell you that till now. Okay. But it's good stuff to know. Oh, I don't need this. I need to advance. All right. The natural base E. Why do we say that? I thought our natural base was 10. No, we have a base of 10 because we have 10 fingers or 10 toes, you know. And people, when they're counting, they can get out there and then they need to make a tick over here, count 10 more, make another tick, and that's how we got base 10. But the natural base for our number system is a number E. A number E? Yeah, that's what it is. In many applications, the most convenient choice of a base is an irrational number. Strange, irrational number, and it's E, which is about, I wish they had extended further than this, because this looks like it's a rational number. It looks like it would be 2.71, 828182881. It doesn't do that, okay? You needed to add in some more digits here. After here, they never repeat again, ever. No repeating units. Just happens to be these 4 digits repeat once, but they never repeat again. So this is a true irrational number, and that's called the natural base. Now, as you think about it, e to the 2, we drew that one, and it went up like this. We didn't do e to the 3, but we could have, and it would have gone up like this. So this is between e to the 2nd and e to the 3rd, closer to e to the 3rd. Okay? And there's something really magical about this, even though it's such a weird number. The function f of x equal to x, called the natural exponential function, here's its graph. Okay? Now, in this course, we don't have time for you to ever find out what's so special about it. I hope that some of you make it to calculus. You'll get there, right? Oh, come on. But when you do, you'll find out when you're differentiating this, when you're integrating this, this will be your favorite function in the world. Because the derivative of e to the x is e to the x. Integration of e to the x is e to the x. It's just the most natural base of our number system in a calculus sense. And that's what matters. Okay. So that's the number e, an irrational number that you can, it's on your calculator. You got the e to the x key, plug in the values, and you can plot every one of those points. Okay? If you plug e to the 1, you'll get that number there, and you see that the digits just repeat, repeat, repeat. Not repeat, they go on and on and on. Okay. How's our time? Oh, sad news. This is a day you've been dreading all term, isn't it? The last day of class. Okay. So get over it. We will have a final, so we can redeem ourselves there, but we will go from here. Okay. So We'll see you Tuesday morning. What time? 8 o'clock, not 8:30. 8 o'clock Tuesday morning, back in our classroom, 205. I don't need a projector to give the final exam. Final exam will only cover basically chapters 1 and 2, 5 questions on 1, 5 questions on 2, basic stuff. You'll probably be through really quickly. Okay? Yeah. I can't hear you. I can't hear you. Chapter 3? No, we didn't get enough material covered. Sorry about that. Okay. Now, the deal, folks, is be here and do your student course evaluations. Okay? Get those done. Yes. Oh, and when you want your papers, let me give you your papers so you can study those for your test. Now, people who haven't finished everything, please, folks, keep your eyes off other people's paper. Don't let anyone see them, because that will just cheapen your grade and make the other grades better. So please keep it close. All right. If you'll come by, let me pass out this stuff. I would have done it earlier, but there were people taking the test. Okay. DB is not here. Krista. Quiz 1. Oh, sorry. Ha. Handed the wrong direction. Cameron. Okay. Dylan's not here. Carla is here. I guess she's still here. Carla. Asia. Cole. Okay, if you have to go, or are you having to go? Okay, then come by anytime. I'll give you the stuff. Okay. All right. Okay. Thomas. Just make it in. Oh yeah, they told me they had a game today. But Asia didn't make it in, did she? Okay. Amina?
Yes.
Ian? Did he leave already? Oh, there you go. Okay. Kendra's not here. Josh had to go. Okay. Dion? Dion?
Excuse me.
Ariana? She has to go. Ariana, she's up. Okay. Alana? Okay. Tara? Didn't make it in today, did you? Hamina? Patel? Kiara is, you're still here, aren't you? Kiara? Ah, there you go. PK? Kit Q? Okay. Oops, excuse me. Darius? Darius, oh, didn't make it in today. The twin still here? Yeah, there you are. There you go. Okay. All right, test 1. Please don't let these get out there, because a few people haven't done test 1 or haven't finished test 1. Okay. DB's not here. Krista? Okay. Is that the grade you want?
Yeah.
Okay, let me make sure that I've got it down, because I wasn't sure if you were coming back. Okay, excuse me. Oh, sorry. Huh? Okay. Krista, let me see that again. That's what I thought. Okay.
No, I thought I had it.
Okay. Okay, Cameron? Dylan's not here. Carlo, you said you weren't finished. Are you going to finish test 1? Huh?
It's still easy.
Not finished on the page. Are you finished?
Yeah.
Okay. Asia? Second? Paul?
Yes.
Ryan?
She's in the email.
Yeah.
Maya's not here.
You'll study.
Thomas still here?
I had most of them. Like, I only got 8.
Alex?
Don't say that. I got mixed up.
What is happening to Alex?
It's like the threshold in the negative right where you start.
Yeah.
Okay.
So I think I got it.
That's two.
Chapter 12.
Yeah.
Did you do it? Okay. I haven't gotten this right.
It's pretty easy.
Okay. Yeah, well, Okay, Alex, what's happened to Alex? Does anyone know?
You working out?
I guess not. Okay, Gray's not here. Aisha's not here. Amina?
I worked out. I was supposed to work out yesterday morning, so
Ian?
I had to do something else.
I need to work out too. Well, I only work out one time out of the week.
Oh, I see. Okay. Kendria's not here.
I'm
Dion?
in college and doing the time, so I can't.
I told you to do it.
Right, you don't have to say because like once you like. Yeah. Smart induction, so you can get inducted next year. Yeah.
I had my leave.
Oh well, you can still be part of it.
Okay, are you finished? What'd you say? Dion?
Well,
You're not?
depending on your
Okay, well,
career,
get it back to me as soon as you can. Okay. Ariana? Is Ariana still
You
here?
get 6,000.
No, I guess not. Okay. Tara didn't make it in today. Amina? Patel? Brandon's not here. Okay. You? Someone say something to me in my hearing. I'm sorry?
What's that?
No, not the other. I'll be there tomorrow.
I would like.
Oh, okay, yeah, I'll be there tomorrow. When? Today.
That's it. I don't know. That's all.
Wait. Okay, Rhodesia, were you through with that? Okay. All right, that was test 1. Okay, several people didn't take it. Okay. Quiz 2. DB's not here. Krista's still here. There you are. Okay. Cameron, second. Okay, Cameron, did you leave? Yes, you did. Jayla? Dylan's not here. Asia? Yeah, sure. Cole? Maya? Not here. Thomas? Aisha's not here. Amina?
Who's your teacher?
Ian left. Josh left. Dion?
I think that's it.
This is quiz 2. Ariana left. Alana still here.
I'm gonna take that.
I came out with a 99 and a 90.
Tara? Not here. Pardon?
She's a night teacher, so she's like part-time. Oh.
Brandon's not here.
No, it's there's
Okay.
different stuff out there. No. Take it here.
I had to take something.
Darius not here.
Take them all here.
Whoa.
You will literally die if you try to do any sciences over there.
Okay.
You finish here.
And Quinn.
Yeah, do like your
And Lee.
Yeah, I mean, I'm going on my favorite too. But like, if I just go ahead and do it, I really don't got to go to school.
All right, test 2. All right, DB's not here. Dylan's not here. Aja. Okay, the rest of them are here that I've graded. I haven't finished all. Yes.
Can I take test 2, or do you want me to wait until I turn in my quiz?
No, you will need to take it.
Okay.
Yeah. Right.
So I can just take it after you're done.
Krista? Krista leave? Okay.
You want me to do a classroom?
Oh, wait. Yeah, but you just finished it today. Okay, yeah. Okay, I still got to grade that. Okay, Kiara just took it today. Bree just took it today. Wait, I've got to get through all this. These are all the ones that have been done today. Okay. I didn't finish it to Darius, or Quinn, or Rhodesia. Nina. Okay. Deborah. Krista. Deborah. Okay. Cameron left. I think it goes there. Jayla? Yeah, there you go. Oh. Maya. Thomas. Okay. Kirsten. Ray not here. My age is not here. Amina. Amina still here. Oh, wait. Ian not here. Josh not here. Ariana's not here. Tara's not here. Why did I grade the people who are not here? I should have graded the people who are. TK. Yeah. I'm in the copy room behind the secretary's desk. Okay, Q to Q stay. Q. All right, I think that has us all, folks. Whoa. Okay. All right. Do your student course evaluations, please. Okay. I recorded all those names. Okay. I'm on the Birmingham campus tomorrow. You coming there? Okay. Okay, well, I'll take it with me. Yeah, Dr. Pruitt's office. Dr. Pruitt's office, B122. Yeah.
Okay.
You know where that is?
I can find
Okay.
it. You're gonna be able to check it this afternoon.
What's that?
The test I just finished.
I don't know. I'm in class until 5:45.
I'm saying, do I come here and see?
Oh, you,
Or tomorrow? Can I pick it up?
okay, tomorrow I'm on the Birmingham campus.
Okay. All right. So what room will you be in tomorrow?
B122.
B122.
Yeah. Academic go. Yeah, tomorrow.
I came last time.
Huh?
I came last time.
Okay. Okay. So are you
This is
coming
my
tomorrow?
quiz and
Okay.
all that.
Okay. And
So
when
now I
are
can
you?
take the test.
Okay, you want me to take a test
I
over
have
there?
I have a class at 11
Okay.
today.
Okay.
And I guess whenever you.
You want to get it started now or not?
What time is it? It's 11.
It's 10.
Yeah.
10. I have a class at 10. I'm sorry.
Okay.
Yeah.
Well, then go to class.
10 to 11:15. 11:15. You want me to come back at 11:15?
Okay,
Start on it?
you can. I'll be in between classes, but I only have 15 minutes. So yeah.
I can try it. Okay, I'll check with you at 11:15.
All right, good deal. Thank you.
I want to take my testimony too.
1 and 2.
And
Okay.
you upgraded my quiz, but they're not in black yet.
When did you turn it in?
Last week.
Okay, well, I'm not surprised because I haven't had any time to reflect on it later. Okay. And you want your test 2 now?
Yes, sir.
And you want your what?
Test 1 and 2.
Okay. Okay, here's test 2.
You want me to take it in your office?
That'll be fine if that next room is open. You want some graph paper or you got some?
Yes, please.
Okay.
I need test 2.
You need test 2 also?
Test 1 and 2.
Okay, let me get one for you first. Okay.
I just want to know what time you're going to be on the bus. Birmingham campus tomorrow.
8 to 12.
Okay, I'll see you at 11:15. Today.
Okay. Today. Okay.
Yes, sir.
All right.
He said 8 to 12 tomorrow.
Okay. Let me find graph paper.
Mr. Fowler, you still recording?
Thank you.